and your surface tag or layering correct, in which case you may find that this might actually be removing and adding a surface to the venue, which will tell you that your importation and your model is not correctly grouped. After you've assigned what layers you would like included in the model, we then need to ensure that our orientation of our venue is orientated down the correct axis. Now, display 3 will always import speakers facing and firing down this forward X axis. So as you can see, forward X. So we need to rotate our venue 90 degrees around our Z axis, our vertical axis, to ensure that we are firing down the forward X. To do that, we can come across here to our transformation tools. So transformation tools allows us to either rotate or offset around any of the 3 axes in the software. So here I can rotate around 90 degrees, and I am now firing my venue across the audience area from stage into the audience area across the forward X axis. That's important to remember, only due to the fact that when it comes to importing speakers, it's really important to have that, because otherwise it becomes quite a mess trying to make sure, and it becomes long trying to make sure you've got the correct coordinates where you are and trying to get the speaker positions. It just makes things and life a lot easier. Once we've got the venue firing down the correct axis, what we then need to do is ensure that we have our origin point. So the origin point, obviously where all 3 axes meet, we need to ensure that that is at the right place in the model. Now, this depends on how you wish to import the model and how you're going to import your model. So, for example, if you're going to be using native venue drawing, so essentially using the native drawing tools within Display 3, then usually we would recommend keeping the origin at the front of stage. This way, when you import speakers, they import on the 0 axis along this axis here on Y, and then essentially all you need to do is move them left or right horizontally to match where they are in space, usually left, right of the center of stage. However, with D2 importation, if your main import method is going to be Display 2 optimized arrays, the best place to have your origin is in the same place where Display 2 would create your 0 point. So in Display 2, obviously our 0 point is always at the connection between the rear wall and the rear of stage. So what we should do here, as this is going to be predominantly a session where we import Display 2 optimized arrays, we should ensure that this origin point here moves back to the edge of stage here at the back wall, so that when we import the models, they import correctly based on the axis and the origins being in exactly the same place. So to do that, what we now need to do is offset on X and essentially come back 20 meters. That's going to be 20 meter stage depth, because we have a 20 meter deep stage. Now we're ready. We've got all of our surfaces that we want to include in our model. Our model is firing down forward X correctly, and our origin point is in the correct place based on what import mode we're going to be using mainly today. After that's all done, you can then click import. Now, once the venue is imported, the venue tab to the left here will display the model with each surface or layer defined by the color and labeling inherited from the SketchUp model. So if you have in your SketchUp model, I just here quickly could find my SketchUp model for you, just so you can have a reference of how that works. Just open that shortly. This way you can have a look and see how that relates. Here, if you look in the workbook here, the workbooks that you've been sent, you'll see that here, that once they've imported all of my tags and layers, so my audience, my goalposts, my mojo barrier, my stage, all of that is imported into SketchUp in the same way. So let's check that. So as you can see, my layer information here. If I toggle my audience area is toggled, goalposts, mojo barrier, and my stage. Perfect. If I come here and I show you, for example, my SketchUp model, you'll see here that in my SketchUp model, we have exactly the same. We've got audience area, goalposts, mojo barrier, stage cover. So they inherit all of the settings and the same color system that you have within your SketchUp model straight into the display free model on using SketchUp import. Pardon me, sorry. As you can see as well, obviously, check it out using the checkbox here will toggle layers on and off depending on which layers you want to be visible. Once you have all your layers showing and are happy that everything is in the model and that you want to continue, you can move on to the coverage tab. Now, the coverage tab is where we assign our coverage requirements based on our venue. So it allows us to define the coverage type related to the specific surface or across defined layers. So these coverage parameters are assigned globally, and this process is common between all venue and import options. So no matter what option you use to import a venue or how you create your venue, these coverage tools work in exactly the same way. Please also, I just need to mention this as well, as it's a guide for individuals who may not be aware, but Display Free is currently a beta software. So we are currently updating this software with new features, added features, trying to get it to the place where we want it to be. However, that's going to take a little bit of time. And users need to understand that Display Free currently does not have or contain any native optimization tools in it whatsoever. Optimized arrays are still designed and the presets are still created using our Display 2 software. The coverage tab in Display Free only allows a visual representation of direct SPL on that surface with the correct offset. It does not account for things like surface materials or reflections. It just doesn't do that. So it's a direct SPL mapping essentially software. The process of the optimization for any optimized array is obviously carried out in our Display 2 software. And obviously optimization at the minute is only currently applicable to MLA, O-line, and wavefront precision speakers. These optimization files can be imported into Display Free if required to show SPL, coverage, and frequent response. However, they cannot be optimized inside Display Free currently. Please also note that all WP, all wavefront precision models are available. Sadly, MLA models and O-line are not currently available in Display Free. They are something that we are currently working on looking and adding to the software. There are a few changes that need to happen for that to happen based on optimization and GLL files. But that is something we are looking to add later. At the minute, it also contains all of our point source speakers. It contains our torus constant curvature. It contains our ceiling speaker range, our adorn speaker range, all of the other loudspeakers that we manufacture. It contains for design. Sadly, the only thing at the minute it doesn't contain is MLA or O1. So, to assign audience coverage. So, coverage tab allows you to assign audience coverage to an audience area, and in future, obviously, when optimization is brought into Display Free, then this will be the tool where we assign where our avoid functions, the tools that we currently use in Display 2, will be. At the minute, though, like I say, I reiterate, it is purely this is purely direct SPL. So at the minute, we can only assign audience area. For example, I can click my audience tool here, come to an audience area, and click that area. It will assign the entire area to an audience area. I can come over to my layer if I wanted to and remove that essentially and click it by layer or surface. It depends entirely on how you've labeled it and how you would like. If you know you have, for instance, an audience layer that is over multiple surfaces, you might want to assign layer and then assign the audience tag to all layers at once, all surfaces at once. Sorry. To remove, simply click the remove tool, click the surface, and it will remove your coverage assignment. What we can now do also is we can also use tools such as our coverage tool. Now, in this design and in this instance, coverage tool is not really useful because we have one audience area. However, if you have a design where you have multiple audience areas, what you can do with the coverage tool is assign layers or keywords to specific layers. So for example, if you go into project settings here, we can actually assign keywords to our audience area assignment. We can assign keywords to our void or our non-audience, our avoid areas, and keywords to allocate hard avoid areas where we want them. We can also then, by doing that, I can simply grab my audience layer and drag it into my audience area. That will assign it straight away as an audience surface, as an audience face at the height that I have set. I could, for example, set my stage if I wanted to at hard avoid. This is not going to have any optimization effect on it whatsoever. It is purely, essentially, an audience area in blue, if you will, effectively right now. However, in future, obviously, this would be how we assign hard avoid coverage, or how we assign non-audience coverage. For the minute though, I'm just going to assign audience coverage and click auto assign. You can also click auto assign there where stage, because we've had stage set up in our settings for a keyword, you can simply click auto assign and it will assign all those words to those coverage types. Really quick, really easy, based on what it is you want to do. For the minute though, I'm just going to include the audience area. Now, once we've created where our audience listening area is, we can now need to look at listing height. So one thing that is imperatively important is that obviously we set the listening height for where our audience is going to be. So as you can see here to the left, we have a uniform height button. We have standing of 1.6 meters, seating of 1.2, or a custom height that you can set yourself. If, for example, you are working in a venue with multiple audience areas with different heights in different places, then you can uncheck uniform height and click standing or seated based on a specific height on those specific surfaces, and it will allocate the difference between them. If, however, you have one audience area like we do today, we can simply just select our listening height, which for this is a festival setting, is going to be standing. And essentially, any change will change this height based on what we do. We'll leave this standing today. Just so you're aware as well, project settings also allows you to set what your average standing height is and what your stated seated height is. So you can set those by default to change them so that these values then become different default values. Cool. So once you've selected your listening height preference, click on the surface layer you wish to assign that listening height to. And again, for example, it will essentially set your coverage the way you want it. Now, just to let you know, the SPL mapping, when we come to the last stage of being able to map our loudspeakers, SPL and show SPL mapping, we will not be able to actually calculate anything until we define our coverage. So it's important that a model where no coverage requirement has been set will show a message at the bottom where coverage is not defined. So if I were to remove this, you can now see that this message here in the bottom right now says coverage not defined. If you see that at all, just remember to go back to your coverage tab, select your audience layer, and assign that to your surface and layers. Once you've essentially defined that, please move on to the loudspeaker tab. Now, loudspeakers, we have various ways. I'm going to divert slightly just from the workbook a little bit, just to show you other ways of how to import various speakers. So there are three basic ways of importing speakers into Display 3. We have native speaker importation. So we can click the plus speaker here. This will give us a window showing all the available loudspeakers that we have in display free. We can also select by range or type or market, depending on what it is and how you're trying to find them. And we can select any of these speakers to be imported at any time within the model. We also have the ability to import subarrays. We're going to have a little bit more of a look on that later. And then the main way that we're going to use today to show you how to import into a SketchUp model is showing you how to import a display2 file. So an optimization preset from display2 that is created. So to import all optimized arrays from D2 into D3, please always ensure you have saved your display2 file as a .mat project file. Okay, it's really important. Display3 will be able to identify all Martin audio optimized arrays saved into a single D2 project file. It allows for quick importation and calculation when looking at full touring systems that contain, for example, your mains, your outfills, your delays, your front fill. And it also allows the user to check arrays in position for any issues, quickly informing the user or designer if further additions or changes need to be made to the design prior to you getting into the venue, and ensuring that everybody has a great listening experience. Please also remember as well that your origin matches the same coordinates as vertex 1 in your D2 file, as I mentioned earlier when importing the model. It's really important that the model is there. If for some reason you forget to do that, you can always come up here to venue, come up to venue orientation, and there you are. You have those transportation tools again that allow you to offset and change where the venue is in place should you need to after importing. So for example, I can offset by another 10 meters if I want to. I can change where my venue is in space based on my origin point. Today, I'm not going to make any changes. I'm going to make sure that we are at the back of stage. Once that is done, once that's been done, we now need to look at showing how to import the speakers. So now we've got our stage lined up and our origin at the right point in D2. There are 3 ways to add a D2 array to your project. The main one, found in the loudspeaker tab, is import D2 array. Okay. You can also come to loudspeakers here and import the display2 array should you wish, or you've also got the shortcut Control plus A. Now, just to mention as well, if anybody is into their shortcuts, you can change these shortcuts to your preference should you wish to, based on what they are, so that you can essentially kind of make your workflow even quicker based on how you work. Now though, we're just going to click import D2 array. Now, whilst we do that, just waiting for the window to appear, we are going to select the first file from which we have. So we are going to select from workbook 1 mains, and we're going to look at showing you how this file is imported from display2. Is there any questions at any point? Is everybody happy with everything so far? All good? I hear no answer, so that's a good answer. So yeah, also it's important to know that all D2 arrays are imported into display3 on the X and so essentially on the forward and vertical axis at the coordinates decided in the D2 file. So if you look at your workbooks right now, the array name, trim height, and vertical array aim angle created in display2's optimization process is also included, along with the array's geometric shape, so the cabinet angles, the amount of boxes and the cabinet angles between them, as well as the FIR filter set, which is created in the EQ tab within display2. Here, as you can see now, it has picked up our festival mains that we have designed within our display2 file. And here we can click finish to import our array. Now, as you can see, the array has imported on X at the distance set in D2. So it has been set at 20.5 meters off of 0 from the rear of stage, and it is at a height of 12 meters in the air. Now, obviously, all we need to do now is move this array into position on our goalposts so that we've got them in place. You'll notice here as well that the speaker inspector, when you import any loudspeaker or when any loudspeaker is highlighted and selected, you'll see that the speaker inspector shows the array name, shows the array type, the specific weight of that array, and also the single point pickup hole should it be required. Now, please remember, it's important to know that we are intending on using a 2-point deployment for this. Generally, we tend to see 2-point deployments on hangs, single point deployments on delays. It might be very well be different in your part of the world. But however, if a single point deployment is required, the pick hole here is identified for efficient deployment. So in the same way, display 2 will show you the hole number and the aim angle at which the array needs to be and the hole number to achieve that aim angle. Display 3 will also give you that hole number so that if you do need to go to a single point or you need to kind of have a look at the differences, you can essentially do that very quickly and know what hole on the touring grid you need to be able to achieve your required aim angle. Snap to the nearest pick point also allows you to quickly define angle based on a single point pickup deployment. So here you can actually, if you were a single point, you could just use snap to nearest point, and that would essentially allow you to snap through all the various holes on the touring bar, as you can see here. It will essentially go through every bar until you get the required aim angle you want. However, for this example, because we're importing display 2 files that we have optimized at a specific trim height, and it's provided us with a specific aim angle to achieve the coverage that we have set, then we'll leave these settings and ignore these settings for today. We'll just use them simply to move the array on Y. So once you've got your array in place, we need to move on Y. Click and highlight the array, and it will also activate the loudspeaker drop-down parameter, drop-down venue. Here we have the ability to move the array on X forward, we can move on Y, we can move height on Z. Now we need to be able to move and change coordinates easily, and this allows you to do so. It also allows you to change the aim angle, which for this example we will not touch because that's dictated to us by our display 2 software and our optimization that's happened in our geometric optimization that happens in the shape of the array. And then here also we have horizontal angle. So this is how we can set our azimuth angle, if you will. So where our array is pointing left to right horizontally based on where it is in space. So right now we need to hang the array from the cantilevers on our goalposts as they would be in reality. So what I'd ask you all to do, please, is move this array to your stage left goalpost. So this inside stage left goalpost here. Now to do that, you can either shimmy across by using the arrows here on the position drop down, or simply just type in 12 meters and it will take you to the point under that array. So take the array under that cantilever point. And now you should have an image effectively matches that underneath the cantilever. Now, once you've imported one array or even a speaker, this is not specific to display 2 importation. This is specific to all stereo loudspeaker arrays or loudspeakers in display 3. We have a symmetry tool that allows you to develop stereo systems very quickly and very efficiently based on either the X or the Y axis. So when you use a symmetry tool, it allows you obviously to create a symmetrical stereo partner to the source that you use, as well as then copying over all of the parameters, the array parameters, and linking those parameters so that any changes then made on one array will then portray over automatically into its stereo partner. Make it really quick and easy to kind of configure and change. any kind of parameter you wish. So we can create symmetry planes, as I said, along X or along Y axis. Clicking here, down to the left here in the loudspeaker tab, you can see symmetry plane. Clicking once will create the symmetry plane on X, and then clicking a second time will create a symmetry axis, a symmetry plane on the Y axis. For today, we're just going to create the X-axis symmetry plane. So we've just got a symmetry plane coming, as you can see, straight from our origin point down the center of our venue. And simply, all you do now to be able to create, now we've created that plane, all we need to do now is assign what speaker we would like to create a symmetrical partner to. So come here to the left, highlight the speaker button here and highlight it and click it in red. And then simply come here to the array or the loudspeaker anywhere you want to create symmetrically and click. This will then create a symmetrical stereo partner on the other side in exactly the same distance from X and from Y, from the origin that the array is. Please ensure, once you have done that, to make sure that before you click any other speakers in your model, that you untick the speaker symmetry button here, purely because otherwise you'll start adding speakers everywhere and it gets a little bit confusing and a little bit annoying. So yeah, so just be aware of that. Sometimes it catches some people out. And it's a good one to know. So now, as you can see, we now have here our house left, house right, stage left, stage right PA. And as you can see, they are stereo links. Everything that I make or change to them will update and will change together automatically. Perfect. So what we're going to do now as well is just for kind of housekeeping. It really helps me to know when I'm getting into kind of really big models or just had a really long day, just to rename things within my model. So with symmetry planes, I always like to know and label my X as mains left right, for example, just so I know that is my left right kind of main symmetry plane that I'm using. If I was using others, just label them differently. You could also, if you wanted to as well, relabel it and with X, just so you know that it is the X axis, for example. Please always make sure as well when you're renaming stuff in display 3 that after you finish, you don't just click off, you press enter so that it actually applies the changes that you've made. Perfect. So we've now got a symmetrical partner. We've now got another loudspeaker that's being created symmetrically on our chosen axis. All our parameters are linked and any changes made obviously will portray over. Now we need to import our outfill speakers that are going to come here on the outsides of our goalpost, just to give us kind of a little bit more coverage towards the sides of our venue here. So what I'm going to ask everybody now, please, is to follow the guide and please import your festival outfill array from the D2 file and from the files that you've been provided, festival mains and outfill workbook 1 in the resources folder. So to do that, I'm now going to come here to import D2 array. I am now going to open this up and we're going to go festival mains and outfill touring. This will now hopefully, here we are, this will now produce our previously imported mains array and now give us our outfill array that has also been designed in display 2. So for this example, please choose your festival outfill array and click finish. Now, for the second, I'm just going to remove my symmetry plane for a minute from view, just so that I can see what I'm doing a little better. So here we have a little eye. You can remove all visual prompts, axes, symmetry planes, speaker planes, or speaker names in one click, or you can come here to the list and simply remove what you don't want to see. For now, I'm just going to remove the symmetry plane just so I can see where my speaker is here. And as you can see, this speaker has now been imported and it is our festival outfill speaker. Please be aware that obviously any naming that you have in your display 2 file, so if you have display 2 files named mains, left, right, delay 1, whatever it be, those names will also portray over into the importation from the display 2 file. So it's really handy to make sure that you've got your arrays labeled correctly in display 2, so that when it comes into display 3, you know what array is what, rather than just a bunch of 12 cabinets of PL with no real knowing of which one is what, and they're all different kind of angles because they're all doing slightly different coverage requirements. So it's really handy just to make sure that you're labeling things, just to make sure that you're aware of what you're doing. Keep your workflow efficient. So as you can see, we've now imported the array, and we now need to move this array under our far stage left cantilever. So we're going to be covering our outfills. So to do that, can you please move this array here by 20.8 meters on Y? So let's do that together and come to Y, 20.8 meters, and move it underneath the cantilever. You can, if you wish, just use the arrows if you want to, but it's very, very quick and easier, much quicker and easier just to type the figure if you know it. What we now need to do, obviously, is look at the azimuth angle of this outfill. Now, to do this, usually we would look at things like look at the dispersion properties of our main speaker, have a look at coverage to see where we start to come off axis from the dispersion of our speaker, and start to see where we get to kind of our down up to our -6 dB point. And obviously we want our outfill to kind of take over from that point whilst kind of joining together, so that we end up with effectively no change in SPL or similar, very, very similar SPL, so that our entire audience area has the same listening experience. So to do this, what we need to do is we need to change the azimuth or horizontal angle of this array. So to do that, obviously we have horizontal here in our position. We can do that here. So to change that, simply type in 35 degrees. Pardon me, sorry. Type in -35 degrees. That will change that azimuth angle to then match what it is and what we require for it to do, covering to the sides of our venue. What we could all do now as well, just to make life easier, is to use our symmetry tool again, our main left-right symmetry tool. I can toggle it back on here in the window here, just on the left. And then what I'd like to do is assign to my outfill and create a stereo partner there, stage right. Perfect. Please then come to the loudspeaker. If you click on the loudspeaker, you can see here that we have various, all of our mains and our outfills now in the model. What we need to do now is move into labeling our arrays appropriate to what they are. So obviously we have outfill, we have festival mains, but it's nice also to have these in our SPL tab in our sources list. So once you've imported all arrays, you're happy that all outfills are facing the right way and your mains are facing the right way, please move on to the SPL tab. Now, in the SPL tab, which is the final tab in display 3, pardon me, we have the ability to create what's known as source groups. So source groups is where we can group various sources together so that we have global control over those, rather than having to have individual discrete control over multiple sources and having to make multiple changes. We can allocate multiple arrays to a source group and make one change globally. Again, making workflow efficient, making it a lot quicker and a lot easier to work. So to create source groups, what we need to do is come here to our sources section in our SPL. And as you can see here, I've got my festival mains, I've got my mains linked, I've then got my outfill, and then I've got my outfill linked. What I would like to do, please, is create two source groups. One where we're going to call festival mains, we'll call it mains, and then the other we're going to call it outfill. So to create a group, so just to answer a question that's just come up in the chat, Fabio has asked, may I use only D3 to design a venue, or do I need to import data from D2 for all designs? So if you are, you don't need to import, you can use D3 to design a venue as long as it's not an optimized array. If you want to design any venue using optimized arrays from Martin Audio, whether that be MLA, wavefront position, O-line, all of that process of actually creating your optimization must be done in display 2. It then needs to be imported into D3 to visualize and show that visually to your client. You can't, at the minute, there is no native optimization available in display 3. It is something that we are currently working on and is coming in the near future, but it is something currently at the minute is not available. If you, however, just wanted to do a basic point source design with some of our point source speakers or with some of our constant curve Taurus boxes, you can quite easily import those speakers into a model quite easily. They're all available there, and you can quite easily draw venues. So not a problem at all, Fabio. So continuing on, source groups. So here we need to label our groups. So to create source groups, we can either come here to the group button in the sources list and click that, and we're going to create 2 groups. The first group, to be able to rename, you can simply double click on the name, and we're going to call this mains. And then I'm going to click on group 2, and I'm going to call this outfill. What we're then going to do is drag and drop our mains, so our left right mains, and then our outfills into their appropriate groups. So we can either drag them one at a time, or we can group together, shift click, and then drag our mains into our mains, and then again shift click our outfills, drag them into our outfills. And now you can see we actually have one global control for both our arrays or both our outfills, depending on what it is you require and what you need to do. Really, really easy, really, really handy. Now, groups can be expanded or collapsed, as you've just seen me do, using the arrow to the left of the corresponding group. And the source group allows you, like I said, to make global changes to mute, solo. You can hide arrays if you wish to. You can also change polarity. You can change gain here in the section here by adding gain to both arrays. We still have individual control by only being able to add individual gain to a discrete source, or adding delay. So you've got all the basic processing requirements and tools that you would be used to and require there for ensuring that your arrays are level matched and time aligned. I apologize. It just stops all that unnecessary repetition. Source groups just allow really quick access to time and to delay for time alignment or gain for level matching. So it's really, really quick, really, really easy to use. If you look at the image now, you should all have all 4 arrays imported. You should have 2 source groups, one labeled mains, one labeled outfill with your left, right stereo mains dragged and dropped and assigned into your mains source group, and then your outfills assigned into your outfill group. So here, as you can see, we have our main arrays and we have our outfills. Now what we need to look at to create a full range system is to give it some low frequency reinforcement and look at subs and look at how we add subwoofers to a project. So currently there are 2 ways to import subwoofers into a project. You can either import them natively, as you can every other speaker, by going to add speaker, coming to subwoofers, SX subwoofers, and as you can see, we have the entire range of all of our current subwoofers that are available in the software that you can then choose from. So everything from our single 10, double 10, single 12, double 12, cardioid 15, our reflex loaded front foreign 18, our reflex loaded double 18, our cardioid 18, and then the my favorite sub of all time, the SXH 218, so the hybrid horn, reflex horn hybrid 2018. This way you can just import a sub and it will import it into the model and you have a singular sub. So if you're doing, for instance, like left, right sub, or you got single subs distributed somewhere because it might be a smaller design or somewhere inside, then you can do that. If, for example, though, however, you are looking at designing some sort of sub array, we now currently in D3 have a subarray tool. So this is actually one of the quickest subarray tools available out there currently. It is very, very effective and very easy to use, but it is very early stages in the minute as to what products are included and to what types of subarray are currently available. To answer Whitson's question about MLX enclosures, sadly, Whitson, MLX enclosures are currently not available in D3. It again comes down to the whole MLA thing where effectively we need to look at how the optimization works because it requires to be updated, if you will, which is what we're currently working on by implementing MLA and everything else and getting native optimization in display free. It's all part and parcel of that, but it is coming. Don't worry about that. If you are ever in a situation where you need to really show what an MLX is going to do, an SXH218 is acoustically exactly the same subwoofer. So the SXH218 and MLX acoustically are exactly the same subwoofer. They are exactly the same enclosures, exactly the same size. The only difference being is the amplification and processing. That's it. That's the only difference. So obviously there are going to be slight differences, but when it comes to subwoofers, it's pretty much going to give you what the MLX was going to do anyway. The MLX might just be a little bit louder. Okay. So that's just for your reference if you ever need to do that and ever need to model them when they're not there. So yeah, sorry, I digress. So obviously then we need to look at low frequency extension. So today we're going to use the subarray tool. So up here on the main project window, you can see in the main toolbar here at the top of the page, click or plus or insert or add subarray. You can also use the shortcut Alt and U will also give you the same pop-up window. Now, today, we are going to use, obviously, we are working with WPL arrays, so it would make sense that we use the SXH218 hybrid horn subwoofer. So we are going to do that, and we are going to add this subwoofer, please, into the project. Now, as you can see, the subwoofer has imported at 0 on the origin. Hence why, when I was talking about earlier about importing native loudspeakers, it makes sense to have the origin at the front of the stage, because then all we would have to do is move on Y. We wouldn't have to work out the X distance as well. However, for this, it's not an issue. We can just move it. So, for those of you who have not used the subarray tool yet, the subarray tool enables the rapid design of ground deployed linear arrays of subwoofers. Please be aware that traditional techniques have been used to determine the EQ required to approximate and steer far-field beam forming and farm-field beams. An emphasis has been placed on the speed of design using a handful of really kind of quick and easy to use parameters, rather than requiring manipulation of individual loudspeakers, associated processed elements to achieve your coverage and achieve a result. This tool allows very quick results, very quick, gives you very good results very quickly. So once you have added the subarray, we now need to look at moving it. So if there is ever a point as well in the future where you might not actually be sure as to what type of sub you may be using, you may have access in your inventory to SXH, you may have access to S218s. It really doesn't matter. You can import the array and then change the type of the array later on here by changing the box type that's available. So you're not restricted once assigning what type of array and what model to use. You're not restricted to that one model. You can then change it later on very easily. So don't worry about that. So now the subwoofer, as you can see, because it's a subwoofer, it is not only imported at 0 on the origin, it's also imported at ground level. We obviously have created default settings so that subwoofers are imported at ground level, arrays are imported in the air, point source speakers are imported at certain height. Now you can actually change these settings again, so you can actually say where the default heights for the added speakers actually are imported in on the z-axis. So for flown arrays, we can with default is 10. Flown clusters, so torus constant curvature, will be imported at 5 meters. Single loudspeakers such as your small point source, CDD, stuff like that will be imported at 2 meters from ground floor level. And then subwoofers will be imported at ground floor level. If you have any preferences to, for instance, if you may be working with the same structure, for instance, that you're supplying as part of supplying an audio package to your client, then you might have a known structure that you always use on every gig with this PA. You might want to change your flown array height to that, for example, so that when you're playing with arrays in the software, it will always import there. Makes just life quicker and life easier again. So please also be aware that when you've imported a speaker, the inspector allows you to also rename the speaker. So what I'm going to do here is just rename this subarray as subarray 1, just so it's clear and easy to know what we're doing, where we are. And as you can see, that is now called subarray 1. Again, it'll also give you the weight of the entire array and also wherever the location is ground stacked. Please note, currently at the minute, we don't have any flown option to create flown subwoofer arrays currently. It's purely ground deployed linear arrays. Obviously, this is something that's going to come in the future, but at the minute, currently where we are, it is ground deployed linear arrays only. Once you've renamed your subarray, please then move this subarray on X by 21 meters, please, so that we come to the front of the stage. As you can see now, I've moved by 21 meters and our array is now in the front of the stage in the pit area between the front edge of stage here and our mojo barrier, where our crowd barrier is going to be there. Perfect. Now, when it comes to subwoofer arrays, currently there are 3 types of array available in the software. So at the minute, if we just close position, so we know what that is, there are 3 types. So we can come to array type here, and we either have the option to create a broadside stack subarray, a broadside row subarray, or a castellated broadside subarray. So other common deployments are obviously going to be added in the future, things like N-flyer arrays, delta arrays, possibly different types of subarrays depending on what we require, as well as the option to be able to have full range flown variants. So for instance, if we're optimizing in display 2 and having a full range array that's been designed with subwoofers to be flown above it, and that's been designed in the display 2 file, that will obviously portray over as part of the whole array with the flown subwoofers into display 3. However, currently we have access to the tools we have currently. So for just to be mentioned as well, for broadside stack and broadside row, please note that any of the box types, any of the subwoofer types in the software currently available can be chosen. The only time you will not get access to all of these subwoofer types that we have in our portfolio is when you choose castellated. And that is because when castellated, the only options for subwoofer choices that you get are those where the cardioid configurations are already defined in the settings of the speaker itself when imported. So please be aware that when you're creating these subarrays, anybody used to, for example, using the old the old subarray spreadsheet, it would tell you what the offset for center frequency would be for your cardioid rejection in relationship to your front firing, and then you would need to include that offset and include that time offset. For example, it's 5.5 milliseconds for MLX, 3.5 milliseconds for SXH, you would always have to remember that figure so that you can then include that in your ViewNet file, so that you have the time allocated correctly. Please note that in display 3, the cardioid configuration, so the time offset, the gain offset, and the polarity inversion is already included in that preset. It already knows when you are forward firing or rear firing what preset to use. So please don't add the additional time on top, because then that will obviously make everything out of time. So if you ever come through an example, you come through a need where you only have access to a certain subwoofer that doesn't have its cardioid settings defined in the software, please just email technical@martinaudio.com, martin-audio.com, and me, myself, Ben, Robin, Nigel, or Dan will be more than happy to help, and we'll basically give you the figures and give you the settings you need to create the cardioid preset for that subwoofer. So to show you, today we're going to use castellated array, just to give you kind of, for those of you out there that may not have come across them before, who or may never seen them. It is one of my favorite arrays, purely because it is very, very, very effective for pattern control. However, obviously there are different approaches for different requirements. So if you're looking for excessive output and coverage over great distance, then one, you probably don't want ground stack subwoofers anyway, and two, you would probably want something like an end fire arrangement, something like that, or a hybrid arrangement of some sort. This is something that's all going to be added later. At the minute, we only allow for castellated broadside stack or broadside rows, and the castellated will always give you really nice horizontal coverage, really nice kind of control in your beam as to what you're trying to achieve. Very effective subarray. Also achieves absolutely amazing, really, really effective cardioid rejection behind. Especially on stage, which is where that's most of the time is the most important area to have rejection, based on that's where our microphones are going to be, and that's where we don't want a lot of sound or a lot of noise on stage, because that's when we start to annoy monitor engineers and start to annoy musicians. So let's so have a look at castellated arrays. Really, really good. We're going to have a look at building one right now. So SXH218, we're going to choose castellated array type. And then the next option you get to choose from is the preset type. Now, there are 3 preset types for castellated subarrays in display 3. The first one is bookend. Bookend is where the end, so the end elements, if you will, of an array. So to do this, let me just create a few more elements so we can see. So bookend is where the ends of the array are always 2 boxes high, okay? We've then got buttress. So if we choose buttress, that is where the end elements in an array are always 1 box high. And then we have uniform, which is where we have basically an array that consists of various L-shaped sections, sources, if you will, yeah, that combine together to create a single source. For this today, we're going to create bookend. We're just going to select bookend, purely because it gives us really, really effective cardioid rejection throughout the length of our array. And now we need to change, or if you need to or required to change landscape, orientation here allows you to do that as well. So you can actually change whether the orientation of the array of all boxes are either portrait or landscape in the array, and this can be changed here. So we can change portrait if we want to. However, we might start to annoy certain people on stage if we start to obscure their view or the crowd's view of our artists. So we'll keep them landscape for today. Now, just to explain how this works, the next section in the subarray tool is our element section. So this is where we actually define where the elements are, or what we define as an element. Now, we define an element as a single or group of subwoofers, which is the structure or entity which is replicated in a linear pattern. So, for example, Here we can look here. Here I have 3 elements. I've got 1, 2, 3 elements of bookend castellated array because we have 2 high. Okay. Now please know that each array type generally has a different patternable element. Okay, so for broadside stacks and rows, then the element is the stack and row, which consists of 1 more sub boxes. Okay, so for instance, if I were to change my type of array here, so this is 1 element, this is 1 element, this is 1 element, or stack, if you will. If we then went to broadside rows, this is 1 stack, 1 element, 1 stack, 1 element, 1 element, yeah? And then when we go to castellated, 1 element, 1 element, 1 element, yeah? Okay. Now, you can change the number of subs in a stack or element quickly in the pattern section. So when we have, sorry, I forgot to mention, if we have a cardioid, an array where we have cardioid settings defined, i.e. a castellated array here, we can actually define what level and time offset you have between your front firing and your rear firing cabinets. If you, for example, are using broadside stack subwoofers, here we can actually dictate what subwoofer is our rear firing. So if we want rear firing on the bottom, rear firing in the center, depending on where we want the control effectively. We can change that value very quickly here by setting which box or which row is our cardioid row, and then setting how many boxes there are, how many subs there are, or how many elements there are. Really, really quick and really easy to define. Right now, though, as I've said, we're going to go castellated, and we'll keep it as castellated. Now, please understand as well that any of the values you change, either per stack or element, all of those settings are then copied across all stacks and all elements in the array. For subarrays that use a subwoofer model that has cardioid configuration included, such as this, here you can select what row in a stack element is rear facing and allowing to correctly orientate your array. And then checking the cardioid box with broadside will allow you to do that as well. Now, because castellated elements consist of whole or partial L-shaped groups of subwoofers that contain their cardioid configuration, so their EQ, their level offset, all the processing required to allow the software to know it is a cardioid configuration, you need to be able to change level and additional delay on a row basis. So each sub in that row will be affected. So here we actually are affected by the top row, which is the rear firing subwoofer firing onto stage, and then the bottom row, which is the front firing subwoofer row. And here we can change level offset between the 2 sources, or the 2 rows, or the 2 elements, if you will, within that array. Pattern section allows you to set the total number of subwoofers or elements used to construct your array. Now, changing one of these will automatically update the other, purely because what we don't want you to do is to create arrays that will not be coherent. So in order for a castellated array to be coherent, we always need to make sure it consists of those L-shaped arrays, separate L-shaped structures that build the array. So the number of elements can increment in steps of 1, depending on the array type. So if I had, again, for example, if I had a broadside stack and I just wanted to add single boxes, they can increment in 1 quite easily. However, again, because the tool is designed to give you a quickly deployable, very coherent array, it will not allow you to create divisions or divisions of cabinets that will not give you a coherent response. So therefore, we can set, for castellated arrays, we can either set and choose how big our array is based on pretty much how many subs we have on the truck. So if you know the kind of maximum number of subs you have coming in from your provider, or that you're providing to site, or if you're getting kind of really deep and budget is no question, and you're looking at how to create the best possible subarray based on endless access to equipment, then you might be looking at this from a perspective where you're looking, okay, how much control can I get out of this? Let's really look at creating a real fine control of what I require from my venue. Then you can look at creating your subwoofer arrays based on the amount of elements you require for that control that you want to create. So please notice as well that all spacing properties are linked together. So changing one will update the rest. So for example, if I change the upper frequency from which I want control up to in my array, it will automatically update the acoustic center distance from one source to another, as well as then the physical gap difference in between the side of each box. This again is designed to allow people to create very coherent arrays very quickly. Please also know that arrays, the minimum distance in any subwoofer array is restrained to the gap of 0. Okay, you cannot obviously push one subwoofer into another because we don't deploy them like that in reality, and this is the minimum distance that we can achieve. So please also be aware, for those of you looking at cardioid configurations, that the upper frequency that we have here that stipulates what the highest frequency from which we have control up to in our array is based on a half wavelength condition. So as I'm sure you're aware, it needs to be treated with a little bit of caution, as depending on how much processing and how much beam control is applied, it can start to make them, they can start to be kind of optimistically high, if you will. So just please ensure that when you're designing arrays based on, say, the highest frequency you want to control, to ensure that then when you come to maybe using beam forming or essentially start to create your horizontal control in your array, that you're not you don't have too much processing in your array, because as we all know, having too much processing in your array and having essentially too much time going out towards the sides of your array can create some very, very odd and very, very naff sounding subarrays. So just be aware of that one. There are limitations, obviously, to this. So for the example today, we're going to again select castellated subwoofer. We're going to create a subwoofer array that consists of 20 subwoofers, which is going to now produce 7 rear-facing subwoofers. So 1, 2, 3, 4, 5, 6, 7 rear-facing and 13 forward-facing subwoofers. And if you have a look now, your subwoofer arrays in your project should now all be matching the subwoofer array in my project that you can see here. So once you have done that, you can move on to the SPL tab, please. Further into the SPL tab, and then we'll look at this. So now we've got our subarray in place, it might be nice to actually start to look at the result of what some of these sources are doing in space and how they're working. So what we need to do now is ensure that our SPL parameters are correct. And we're just going to go through these parameters, what they are and how they work, just so that anybody that's never come across them before is aware of what they do. So what we're going to do today is we are going to set our parameters, please, to as such. So I'm going to set my input source to music, please. Now, input source is here, and it basically gives you different input sources based on what you may want to analyze or what you may want to use as your input source material. So if you want to use pink noise as a reference, so that when you get into the field and you get your measurement microphones out and you start pinking systems and you want to take some transfer functions, you can then use these to kind of look at and compare against. We've then also got different curves. So these are different curves based on different input sources, if you will. So dance music has a little bit of an LF increase, a little bit contour, if you will, towards target curve, towards a bit more LF content. You've got IEC 2681, standard input source testing signal. Pink noise, obviously all frequencies sorry, all frequencies at the same level. You've got speech and then music. For this example, we're just going to use music, which is obviously just kind of like almost kind of like an A-weighted band pass input source, if you will. So what we then also need to do is then ensure that we have the maximum volume level available in our system. So this max button here will basically apply the maximum headroom found in the entire system, and then attenuate the input signal to allow for that. So always make sure before mapping that you have max clicked, so it's there. And now all we need to do now is set our settings so that we can now move this. So we now have bandwidth preset. I'm going to click sub because I want my sub 30 hertz to 100 hertz bandwidth. Resolution it doesn't really isn't really applicable. So we can have 1 octave. You can do third octave resolution if you like to. Third octave at 50 hertz, for example, is a common one. However, because we're setting our bandwidth, we're going to use broadband, and then we're going to have no weighting applied to subwoofers. We don't want to have any weighting whatsoever applied to the result, as we want to get kind of a visual image of what our subwoofers are physically actually going to do in space, not based on when a human's listening to them, for example. So we can now, if you want to, you can now simply come to the subarray at the bottom, and make sure, please, at the bottom here is a little S. You can click solo. What this will now do is solo that subarray and show you the results of what that array is about to do. We're going to produce. Now, obviously, depending on your computer, it could take longer, it could take quicker. It really depends on your system, on how well and how quickly this process happens. I will mention here, actually, that if you're in a situation where you're just doing kind of quick visualizations as kind of an initial design, here underneath the SPL legend, you've got what's called mesh. Now, this allows you to assign how quickly or how into what detail you would like the calculation to show. So, for example, course is going to give you a much quicker calculation where you might not have visually be able to see the interaction between sources or what's happening in as fine a detail. So, for example, if I zoom in here and go course, you'll see that it's not in as fine as detail once it's updated the SPL. And it's just a tool that we use depending on how big your project is, whether to get a quick result. If we just need to see a quick result of, I just need to check the coverage of that one array, I can just do it coarsely and just look at it quickly. If we're producing the end visualizations that we're going to be sending to the client, then obviously we want them to show as much information as we can. And if we get it now, I can then change to normal. It makes no changes whatsoever to any of the parameters in the software. It just gives you a difference in how fine the image looks, so you can actually see the interactions between sound sources and what's happening acoustically in that environment. For now, we'll just leave it on normal. It's effective, it works, but it's there. So as you can see, it's now plotting our subarray throughout our audience area. And you can see here there's a little loading bar here. It just shows you progress of where our calculation, SPL calculation, is. And what we're going to do now is just look at different ways in which the sub can perform, and just look at different ways of kind of changing the coverage requirement for our sub. If we look at this here, obviously this is the end of our audience area. our audience area is actually, if I bring this in just so I give you this as an example for comparison. Sorry, just a bit glitch there. If I bring this here into the window here, you can clearly see here that this here is 80 odd meters. Let's say 80 odd, say 80 meters deep. Okay. So if we actually look here. Oh, sorry. What's going on? If we actually look here, we don't need coverage over here. This is going to annoy neighbors. It could be off-site, whatever the requirement be, but it's not where our audience area is. So what we can do is actually play with our subarray tools to get and achieve coverage where we require it. So what we're now going to look at is the beam section in the subwoofer array tool. So the beam width or the beam section, beam width can be used to electronically steer and control your array's dispersion to help improve your low frequency coverage throughout your audience area. Now, beam width itself can be set from 1 degree, okay, to 180 degrees, all right, depending on what it is that you're trying to achieve and how much you require. For those of you, okay, so I apologize. For those of you where you've just had your optimization turn all black, that will be because of the SPL settings in your project. So to rectify that, Francisco, if you come to your project settings and come to here, what you can do, okay, is change the range and scale of what it is you're going to be doing. Now, for this example, you might want to change it, for example, to like 48 dB, just to give you a range of scale. What that will do when saved is it will then re-optimize and give you a higher scale, essentially a higher limit and a lower decibel limit for you to then work through, okay, and work from. It's purely because it's gone black because for some reason the scale will say black is 96 dB. So the scale was always appropriate. So always obviously look at what the color is saying, what the color is appropriate to the value, because it's always appropriate to that value. The coloring scaling works slightly differently in Display Free to other softwares where you expect kind of like a traffic light system. It is something that we are looking at changing or maybe working and developing further in future based on user preference. So if there is anybody with any kind of user preferences and stuff like that out there, it's always handy to know. So always kind of push those to the team out there with Berenice and Oscar and Carlos, or anybody at Martin Audio. If anybody has any kind of ideas or anything like that they think would be very good additions to the software, always up for listening to that. So please let us know. Awesome. Glad you got that sorted, Roger and Francisco. Brilliant. So yeah, so here, as you can see now, we've now got our sub array showing. However, you can also see now, because we've increased our range, that it's really hard now to see what coverage is doing. But now you can still see that we are effectively 122 dB here in the near field, and then say 77 dB here in the far field. Okay, so you still get some reference as to what's happening and what's going on. Yeah, so as I said, beam steering, beam width can be changed from 1 to 180 degrees. Please be aware, okay, now this is very important. I'm sure some of you are aware of this, or most of you are aware of this, but please be aware that having extreme values such as 140, 160, I mean, asking an array to do 180 degrees worth of coverage is more than likely going to provide very unuseful results, okay? As we all know, what that will do effectively is push a lot of time into the ends of your arrays, which will then create a lot of time smear throughout your array, and it will basically end up with your array sounding very, very weak and not being very effective at all. So what we always need to ensure is that you still obviously apply your understanding of physics and understanding your understanding of how sound works and how, especially how lower frequencies work together, so that you don't try to design something that when you get into the real world and you get into the field, it's just underwhelming and it just isn't doing the job for you, and you could probably achieve something a lot better if you're just aware of the limitations of adding severe amounts of time into your arrays. Okay. So yeah, you will effectively breach the point of diminishing return. So if I show you for a second, just so I can show you from it, you don't have to change yours, but I just want to show you, just so we can clearly see what this sub coverage is doing. If I start applying 180 degrees, 190 degrees, or 180 degrees, 90, 120, 140, you basically get into the point of reaching the point of diminishing return. So there's no point in doing it anyway, because you're not actually gaining anything in the horizontal to what you are if you had not done it that far. So you'll probably find, for example, setting less horizontal width, so probably going up to 120 degrees, may actually still give you the coverage you require. So always have a little play. It's always good to have a little play in there. So what we're going to do here is set, just for example, is set our width to 1 degree. We're basically going to ask our array to create a 1 degree arc. We need to ensure that for this beam width parameter to make a change and be applied to the calculation, that we have calc SPL checked. Okay. And then as you can see now, apply here has now got an orange. That's the software telling us that we have made a change that we still yet to have applied to our model. Okay, so everyone now, 1 degree, make sure calc SPL is clicked, click apply. And what will happen now is we will now get the software render a 1 degree arc for us from our subwoofer array. Giving us even further coverage way past the perimeter fence where we don't need it. Now, please also be aware that when you're using the apply button in the beam section, okay, when you click the apply button, okay, so for example, let me just unmute everything here. When you change this value and you click apply, okay, it will automatically solo the array, the subarray for you, mute all other sources in the model, and just give you a quick plot of what that array is now going to do based on the parameter change that you've made. So it's very quick, very easy to see differences between different width settings, different shading settings, for example, to get to your desired coverage. All right, very, very quick, very, very easy. Now, let's have a little look at the width. So now we're aware that clicking apply will solo our subarray and then plot the SPL result in the model. What we now need to do is increment the width so that we can get back to our desired coverage that we require, because this again is firing completely offsite through our perimeter fence. It's not really going to give us the result we want, and we're probably going to annoy some neighbors if there are any, or any noise restriction requirements. We're probably going to create some issues here. So let's try and see if we can get a more effective distribution from our subwoofer array. So to do that, we can increment width. So quickly, I'm going to set this to 15 degrees. As you can see, parameter change has happened. I'm now going to click apply and see how that works. And see if that's improved our coverage. And as you can see, we're getting a little bit wider, but it's still not effective, still going way past our perimeter fence, so it's still way past that point. See how it renders. I do apologize for this. My computer is trying to do display free whilst also online video calling, and it's, yeah, it can get a little bit laggy, so I do apologize if it's lagging slightly. Here we are. So that's a 15 degree beam. Okay, let's try a 30 degree beam. Let's see if we can get a better result. Now, click apply. I'm going to go through and have a little play. Everyone right now, just have a little play with width, incrementing width from 15 degree increments, if you will, all the way up to, for example, 90 degrees. So let's just do that. So if we do 15 degree increments, all the way up to 90, just so you get an idea of how this section works, how it maps, and just giving you a kind of a little bit of a time playing. Francisco, it's still black. Okay, so can I just check, Francisco, did you change your project settings? So if we go back to settings, I'll show you. So SPL settings, if you're having your images go black, if you change your SPL settings to a max of 105, a step dB of 6 dB, and then a range of 48, and please also make sure that auto is checked. Okay, Francisco? And then that should give you the settings that will be exactly the same, and you'll see what I'm seeing. No problem at all. Cool. So it's 30 degrees. As you can see, we're starting to get wider, but we're still breaching our perimeter. So let's go a little bit more. Let's go 45. See what that gives us. And as you can see as well, is once display 3 has kind of done its initial calculation, it retains that information. So each calculation after that should be quicker. So it's not like you've got to wait ages for every calculation. But then obviously, if you have a design where you've got 8 different arrays, a subarray, front fill, all of it, then obviously it's going to take some time to calculate. So always be aware of that if you're ever in time constrained situations. So yeah, so 45-degree beam. Here we go. We're starting to get a bit more width out of the array. Still coming there. So let's keep going. Let's go all the way up to 60. See what that does. And this is what we would do. We would usually just keep playing until we get to the desired coverage that we want, where we've got basically the best result from considering all the factors that we need to, whether that be a limitation in the amount of boxes we have access to, whether it be whether it be we have a specific requirement or issues with buildings or something in the way, whatever it be, you can kind of play with this software to really get your design to where it needs to be before you even walk into that venue. Awesome. So that's 60 degrees. Cool. We're going to go 75. See what that's doing. And as you can see now, whereas before we were kind of like 75, 84 dB here, now you can start to see actually we're starting to get to kind of like 100, 102. So you're starting to see that we're starting to create that low frequency coverage on our horizontal plane now, which is really, really nice. Okay, and then last but not least, we can go 90. We can click apply. 90-degree arc is a common value. It's used quite a lot. It gives quite a nice relationship between output and control in horizontal. But obviously, it's always dictated by the amount of sources that you have, array length, etc., etc. So this is why this tool is really, really good and effective in just seeing what we can achieve based on the amount of boxes we've got. So it's really, really quick, really easy to use. I love it. There we are. So now we can see actually that we've got quite nice horizontal coverage now. And yeah, really good. If you really, like I say again, if you really want to get into fine detail and see what these arrays are doing, what the subs are doing, you can change these values and just decrease your range value, and you'll start to see more information, start to see what's physically happening here. So yeah, so look here, we've got 120 dB here right in the near field, 2 meters away from the array, as you would expect, and then coming through all the way into the far field, which is 80 meters and back, we're probably looking anything from 92 to 95 dB at the back here. Still seeing all black in the calculator. Okay, so can I just check, please, that you have just everyone. So let's set to 48 dB range, 105 max PSPL, 6 dB step, and please make sure that your auto calculator or the auto scale is checked, please, when you're doing it. So auto scale, and then that will automatically update your SPL legend to that. And it's still not changing it, Ricardo. Sorry, Ricardo, it's hard to do this right there. So is the whole surface black, or is there any color orientation based on kind of the SPL level at all? Is it purely black? Can I make sure, just to make sure, that your array is at 0, very small color at the edge? Okay, so let's see something. So look here then. I apologize. Very small color at the edge. Francisco is the same. Ricardo is the same. Okay. Very odd. 2 seconds. I'll just wait for this to update to see if this makes any change. No, that makes no change whatsoever. So I'll do that. 105, 36, long distance summation splits. Holes. Yeah, that should make no other difference whatsoever. Yeah, no, it should. If you have what was the issue, Ricardo? Sorry, have you found what the issue was? Just so I know, I just want to know then, just make sure, just in case it ever happens again. Acoustic shadow was checked. Perfect. Yes. So yeah, please. Sorry. Please make sure acoustic shadows is unchecked. Thank you, Ricardo. No worries. Francisco, if you haven't seen that in the chat, go into your settings and SPL settings and uncheck acoustic shadows. You should now have, and as long as you've got the same settings I have, so let's go back to 48, the same as everybody else. As long as I'm just going to uncheck that, make sure my auto scale is checked. You should all now have the same image as I have. Perfect, Francisco. Thank you for that, Ricardo. Perfect. Glad we're all now back where we should be. Awesome. Okay, so now we've got to the point where we're happy with our horizontal beam. Then now what we can also do is actually tell the software if we need to direct this anywhere. So say, for example, we've got some food stalls or some food vans or another stage, for example, happening here. We can actually direct and change the direction by a modest amount using the direction tool. So if we come to direction and just type in 20, again, parameters have changed. So the apply button has become orange, showing you that you need to click apply to apply those changes to the model. We can click that, and you'll see now that we'll get a 20-degree change in offset in direction. So as you can see here now, we're now facing 20 degrees towards stage left, if you will, and now we've removed coverage from stage from covering to stage right, and we've now removed coverage from stage left. So yeah, so it's really handy tool to use. really tool, really cool. So if you need to do any kind of like direction stuff and like really quick to do that. Not like other tools where you've got to work out kind of the time differences between each source, and your processing differences between each source, apply them to each source, and then map them together. It's just really quick, really effective to use the subarray tool. For today's session, we're just going to set to 0, okay? But it's just to show you that it can be steered left to right if you require it to as well as a source, as an array source. Boom, boom. Next part we're going to talk about is we're now going to talk about gain shading. So gain shading throughout our subarray. Again, please be aware, I must stress, please be aware that obviously adding huge amounts of time into the array, adding huge amounts of processing the array can change the way the array performs. So always be aware of this, and it's always good if you have the ability to be able to do that. I know it's nice to say that, but obviously we work in an industry where we have no time available, and we're always kind of up against it when it comes to getting gear in, and getting it all set up on the line. But it's always good to have a little play, model them in the software, and have a little listen and see what you're getting, and essentially just double check what the software is saying it's doing. It is going to do, and just make sure that you're happy with the approach that you're taking. So yeah, so the next tool. So I apologize. The next tool in Beam is gain shading. So this is where we can control how well our beam, if you will, conforms to an ideal beam. So how well our 90-degree beam conforms to being 90 degrees wide, or sacrificing that control for output, if you will. So it's kind of a nice kind of maximum minimum kind of toggle, if you will, that allows you to just quickly choose between percentages of either basically it's either allowing you to have fine control over your pattern shape versus your maximum output effectively. So the degree of shading, okay, is expressed as a percentage of the maximum, so 0 to 100. Default, okay, value in D3 is set to 40%. And all of the obviously images that you've seen in this session so far have used a setting of 40%. Okay. Now setting the shading to 0, okay, will allow for maximum shape with no gain level offset going throughout the array, whilst turning this slider up towards 100 will start to add gain and start to shade the array, shade throughout the array, with which will obviously sacrifice your pattern shape and the control for maximum output. Okay, so for example, if I come here and go to 0, click apply, I should now have a 90-degree beam with maximum shape and maximum control in the horizontal. So we're getting even further improved coverage here in the horizontal, as you can see in the near field. However, what we might now start to do is sacrifice output in the far field. Okay, so actual maximum output and getting that low frequency right to the back of our audience area. It's a cool little tool to play with based on what it is you can achieve, and you can really fine tune to get your control that you require and get the best out of that array. So as you can see here, now we've gone really wide, got really nice. If I then start gain shading up, so for example, for 60%, you'll now start to see that horizontal coverage will be sacrificed for output, for maximum output. Bum, bum. Excellent. There we are. So we've now got less horizontal coverage in the near field, but now we've got more output. So it's a really handy tool, or we can just go full blown and go, okay, we're going to add more gain shading through the array. Now, also, just to note, as you're doing this, so that was 60%, as you can see as well, is with all of these changes, the configuration box here is showing us, okay, what level offset, what level difference and shading we have throughout the array, as well as time throughout the array, as well as the horizontal aim of each stack or element, if you will. Okay, so then by updating this and saying that I want more gain shading throughout my array so that I get more output rather than control and horizontal coverage, what that will do, I apologize, what that will do is add more level throughout my array, as it has just done, allowing us to have more output rather than control. Perfect. So yeah, really quick, really quite cool, really quite quick. And as you can see here, if I now go to 0% again, I click apply, I now have no gain shading throughout my array, giving me maximum shape and maximum control. Any questions at this point in time at all? Just while I wait for this to update. Again, I'll take no questions as a good thing. Like I say, if there is at any point anybody has any questions whatsoever, just shoot them in the chat and I'm quite happy to answer them as we go along. Perfect. So you can now see that we have no gain shading happening throughout our array, just time happening because of our 90-degree pattern. If I were to remove this and have no, so if we were to remove all time, so I can remove all time. Obviously, because it's symmetrical, there is no time. If I now calculate that with that soloed, we go back to the sub array we had initially at first before we applied any of these changes in any of these parameter controls. Okay, I can now click my 90 degrees. I'm going to have, okay, we'll just do default 40% for now. Click apply. You'll now see that some level offset and some time offset has been added throughout the array into each source and required to achieve that coverage. Please be aware as well that obviously with the Calc SPL button unchecked after applying any changes, the main Calc SPL buttons will appear orange, indicating that the SPL update is required, just as you saw there. Because I didn't want to apply my beam to my pattern, I just wanted to remove all time, all processing. The array was soloed, I just needed to calculate what that was with no processing. Now, often you may want to see the effect of power distribution in the array with changes you make to the beam. So for example, what we can also do is instead of doing it that way, by making sure that way, we can just uncheck Calc SPL. So I can just uncheck Calc SPL, change this to 120, apply that, and it will quickly update and show me that I need an orange button. I need to click either one of the main Calc SPL buttons to actually render that in the image that shows you to do that. Okay, really quick, really easy. So next section in the subarray tool is configuration, which we've just touched on. So the configuration obviously allows you to see the level and delay applied from the beam or the pattern that you've created. The section allows you to manually change these values to iterate to an improved coverage if you want to kind of change it manually even further. You can also then change the, like I said, the horizontal rotation of each element or stack in an array, and each row represents an element. When the beam direction is set to 0, then a symmetrical application of EQ is applied throughout the array. Okay, so when beam direction is set to 0, for instance, here, then a symmetrical application of EQ is applied throughout. This can be overridden by changing the direction to a greater value than 0, or by simply unchecking the symmetrical box found down here at the bottom of the page. Please also note that when you change the values manually, okay, so if I change a value manually to 15 milliseconds, for example, it's not symmetrical, so it hasn't portrayed into the opposite symmetrical side of the array. And also know that when you click symmetrical, it will match that and update that value to match what that value is, okay? Now, applying the beam will overwrite any changes, okay, whilst the calc out button will go, sorry, the calc SPL buttons will go orange, and then applying the beam will overwrite any changes. So here, we're just going to go 90 degrees again, 40 degrees. I'm just going to apply that, and we get back to our 90-degree horizontal beam. As you can see here as well, these have all the values that you would usually have in your ViewNet file. So obviously you go to your output section, in your delay section in ViewNet, and then obviously go to each amplifier channel in regards to SXH, or to each subwoofer or MLX in regards to MLA, and then enter in those times based on the horizontal coverage you required. Please note that future updates coming will contain export functions for such as things like export to ViewNet for subarray values, for any kind of processing values, to allow for even quicker deployment setup. So that kind of horrible period where you spent all this time in the office or at home, wherever it be, before the gig, setting it up, getting and designing a perfect sound system for the requirements that you've been asked to supply for. You get there, and you set it all up and it's all nice, and then you've got to spend half an hour, 20 minutes as a system technician, sit in front of house whilst everybody's going, okay, are we ready? Oh, can we do this? Can we do that? And you're there going, yep, 2 seconds, whilst pumping in individual delay times, individual gain offsets, all of that based on what you're trying to achieve. It can be really annoying and really pedantic. So yes, there is in future going to be various export functions like export subwoofer array tool to ViewNet. So it will just create effectively a D2P file, same as a display file that you then load into the amplifier. It will assign all the processing, all the channels across the amplifiers to that product, and then you just make sure that the correct subwoofer is plugged into the correct amplifier output. That's it. Very quick, very, very easy. And again, if there's anything that anybody feels could be added in future, please always let us know. It's always good to know so that we can kind of incorporate what people were using, how people are using the software, so we can make it as effective as possible for you, because this is what it's for. Okay. Last but not least, we then have in the subarray tool the last section, which is the channel limited section. What this section does is actually show you all of the circuits. So it's the amplifier circuits showing headroom, essentially, and how much headroom is available in each circuit, in each amplifier, based on what you're doing and what you're achieving at the level it's being driven. So it's just a good one to know if you're ever running out of headroom and seeing where you are. Really, really handy. Cool. So that is the subarray tool. That is where it's up to at the minute. Really, really quite effective, really quite cool. I urge you all to have a little play with it. You can get some really nice results out of it. And yeah, just have some fun with it. It's really, really good. And like I say, a lot of updates are coming in the future in regards to different subwoofer array types, the ability to do flown subwoofers, etc., etc. So keep an eye out for that one. Right, next, last section or last bit I want to talk about now is the actual SPL parameters and the mapping. So what's going on here to the left, and what we can actually do with the tools to show our SPL values and show the clients pretty pictures that they want to see. So, for example, SPL mapping, you have input source. So we discussed this a little bit earlier. So we have the option to set what input source we would want as our reference signal. Okay, so different input reference signals can be used based and depending on the type of sound source you want to measure or analyze. Today we're going to set our input source to pink. Okay, and if you could all set your input source to pink, you can now watch all of your system meters go red, just to show you what happens here and why this happens. So You're probably all noticing now that obviously all of the level meters are for our arrays. Everything but our subs is showing that it is being overdriven and that it is clipping. Now, this is because what we are doing is we've currently got the input level at a level where we have run out of headroom within our arrays. There is a lot more headroom in our subwoofers than there is in our arrays, for example. So what we need to do is attenuate the input level so that we can attenuate the whole system to reach the maximum headroom level that we have in any one system as part of the whole system. That way we can make sure that our system is correctly balanced. No product or no one part of the system is going to be overdriven, and we can make sure that we have the correct level offsets and correct shading between sources in a venue to make sure that we get nice, smooth, even coverage throughout. After all, we're using optimized arrays. The whole idea is that we can get an array to be within plus or minus 1 dB of the target that we set within the display software. So we then want to be able to create really nice systems that coherently, when we have multiple optimized arrays coming together as sources, we want to make them coherent and make the whole listening experience, no matter where you are in that audience, the same experience. That's kind of what our gig is at Martin Audio, and we want everybody to have the same listening experience, whether they are 80 meters from stage, 20 meters from stage, whatever it be. It's the same listening experience everywhere, no matter the cost of your ticket. So, as you can see now, as I said, we've got our input meters are clipping. What we need to do is click max. So what this will do is find the maximum SPL in the entire system and attenuate the input level to allow for this. So as you can see, we've now attenuated the input level of all sources to allow for the maximum SPL available. We then, underneath this, we can also set whether we want to see our metering in dBu, dBV, or VU, depending on your preference. We then also have a bandwidth toggle, so we can actually toggle and select the minimum and maximum frequency that we would like to include in our SPL calculation. Or alternatively, we can choose from one of the 5 bandwidth presets. So there are commonly used bandwidth presets here that we have defined based on what clients and what individuals tend to use to want to produce as documents for production of clients or whoever it be. These bandwidth presets consist of a sub bandwidth, so 30 hertz to 100 hertz. We've then got a low frequency bandwidth of 20 hertz to 200 hertz. We then have the very much the important vocal bandwidth, so 4 kilohertz 1 octave unweighted, which is kind of a common bandwidth preset used for showing its system speech and intelligibility. Really, really handy one to show that. It's one we are commonly asked for in all of our reports and our designs. We've then got an upper frequency bandwidth of 1 kilohertz to 10 kilohertz. And then, of course, the classic full broadband 20 hertz to 20 hertz scope of the human hearing range. Underneath that, we've then got resolution. So we can choose the octave resolution depending on the smoothing we require to see, or we require for us in our project. So yeah, so we've got essentially 1 octave, half octave, 3rd octave, 6th octave, and 12th octave, obviously going through into finer detail. You can also choose your bandwidth. So rather than setting a slider or choosing a preset, you can simply just type in a frequency range that you would like to include in your calculation. And as you can see, all the other bandwidth parameters will update to show that. You then, as the last option, we can choose if we wish to apply any weighting to our calculation at all. So, for example, you've got A weighting, which is probably one of the most commonly used weightings, decibel weightings that we use in the industry, which effectively it simulates the response of human ear at moderate levels. It does not take into consideration low frequencies, so it's effectively a high pass signal, if you will, a high pass band pass signal. But yeah, essentially it will attenuate some low frequencies and high frequencies. B weighted, again, simulates human hearing at intermediate levels, favors kind of the mid-range loudness scale, and there is less attenuation in low frequency in comparison to the A weighted scale. And then we've got C weighted, which simulates the response of human ears in loud environments, usually used for peak measurement or for measurement of infra frequency, so low sub frequency stuff, and has hardly any attenuation in low frequencies in comparison to A and B. And then we also have the choice for unweighted, which will produce a flat frequency response of 10 hertz to 10 kilohertz, plus or minus 1.5 dB, with no bias towards human hearing whatsoever. So if you want to see visually what a source is going to do acoustically, just in space with no humans being present to experience it, then unweighted is the way you want to go. So things like subwoofers and stuff, we always use unweighted to show that. Because obviously as humans we don't really hear subwoofers, we feel them more, so that way we will then, when we're listening to arrays, we'll apply A weighting or C weighting depending on your preference. So yeah, so it gives you the options to set what it is you want to include in your calculation. So really standard stuff really that you would find in any kind of software that would allow you to do this. So what we need to do before we start our calculations is we need to make sure our SPL settings are correct. So this is again what we were talking about earlier, where we're coming through with Francisco and Roger, is we can map SPL based on a fixed maximum level, or alternatively using auto by setting the decibel range you wish to include in the calculation. So earlier you would have seen me playing with these, but if we come to the settings and come to the SPL tab, you'll see that we have a fixed scale and an auto scale. Now the fixed scale will show that we have a maximum SPL value, and we can set that maximum SPL value and it will fix to that value and give you color coding based on that value. This is then what increment in decibel increment do we have in between, okay, in between the scale. Or we can set an automatic scale where the software will know how loud each source is in the near field, in the far field, and then you just set a range as to what the maximum level should be available and what the minimum level should be available based on the level produced acoustically at the speaker. So really handy, really easy to know. So please, yeah, sorry, I apologize for what's the set as well. Please make sure that you copy the settings below by making sure that you have a max SPL 105, step dB of 6, range and dB of 48, acoustic shadows unchecked, with long distance summation blend and split SPL faces with holes checked. We're going to leave our scale on auto, ensuring that the tick box is checked, just so that it applies that scale to it then. And now we just need to calculate our festival mains and outfill. We've seen our subwoofer coverage. We're happy that that's pretty much where we need to be for the moment. So now what I'd like you all to do, please, is be able to calculate the festival mains and outfill, please. Broadband 20 hertz to 20 kilohertz with A weighting applied, please. So if you set your settings to this, so if we go to bandwidth preset, go to full 20 hertz to 20k, we'll select broadband resolution, and then we need to apply A weighting to our result. We can then expand the sources list if you haven't already, then unmute our arrays. Dun, dun, dun. And then what we can also do is then, for example, click solo in our mains. So if we click solo in our mains, we're just going to have a quick idea, quick look at what our mains are doing, what our outfills are doing. Okay. there any questions at all or whatsoever from anybody whilst this is just rendering? It's just good to know rather than sit in silence. It's good to have a chat. If anybody's got any questions or is thinking anything, please give me a shout in chat or unmute your microphone, whatever's easiest for you. It's also a good one to note. So you also have viewing tools here at the top of the page, which I'll show you in a bit. So you've actually got perspective. You've got perspective or non-perspective views. You've got plan view, top view, side view, all the different kind of viewing toggles that you can use to quickly kind of work your way around the venue, depending on what it is you want to achieve. It's got isometric view, you've got front back view, top view, side view. And zoom to fit, you've then got perspective or parallel projection view, orbit. So whether your left click is orbit or right click is click and drag. So if you ever right click and hold down your right click drag, that will give you that. Left click will give you orbit around your model. You've then got camera tools and camera properties should you wish to take pictures and save specific angles for client pictures. We've got the viewing tool, preferences that we had earlier, that we discussed earlier, where you can effectively turn on or off your symmetry plane, speaker planes, axes, speaker names, or the actual mapping itself. And then we've got a couple of little things we can look at the end, just to show you the other tools that are available. It's taken a little while to render this one. It's obviously the first time that it's actually modeled the arrays. So like I said before, the first optimization for each source is going to take a little bit longer. And then obviously every time you then recalculate, sorry, I'm not going to use the word optimization, that's incorrect. Every time you recalculate a calculation based after its first calculation, it will be quicker.
Hi, Paul. I sent question instead of chat.
Hello there. How can I help?
Yeah, I sent a question in the chat about Vectorworks. Could it be imported inside the display for you as well?
So Vectorworks, there is no Vectorworks importation at the minute directly into Display 3. However, you can import Vectorworks into SketchUp and then the SketchUp file. The only third-party software we are supporting in a minute is SketchUp, purely because it's a free piece of software that everybody can get access to do the basic things. Whereas Vectorworks obviously is quite an expensive piece of software that's although it's very specific to what we do, and a lot of people do have access to it. There is also then the need for licensing and everything else. And then until we're at the point where the software is finished, we will then look at licensing things like Vectorworks importation, Revit importation, all that kind of stuff as well.
Okay, great, thanks.
No problem. Okay, so yes, as you can see, this is now plotted. We've got our arrays, and I can click top view, and this will effectively change around the origin point and give me a plan view. I can go side on, I can go isometric view, or I can go side. Again, we then get zoom to fit, so obviously zoom to fit in there, and then we get to change whether we are parallel projection, for example, like so, or if we're going to do perspective, essentially. Okay, that's parallel, sorry, and that's perspective. So here we are. We've now got our arrays. Our mains have been soloed, and this is what our arrays are going to be doing and what they're doing. So what we can actually do as well is once we've calculated our SPL and it's shown, we can actually see the results in greater detail by looking at the SPL distribution. So I don't know if you've noticed, but at the top here, at the top of the main window, there's a little distribution button. If you all click that, this will give you the distribution window. Now, what I would advise you to do is select the surfaces in the results that you want to be included. So if in future, or when in future, when we come to including the optimization process in display free, which is not available yet, then we obviously can include our avoid and hard avoid surfaces, should be required to. We can also now change the step increment again, so the decibel increment that we are reading our values in. And you'll be able to see and compare once we have you'll be able to see and compare the results of what you would usually see and compare in a display 2 file. Okay. Now, as I said, set the step increment to 3 dB. Down here to the left, we have then got an image. I'll just blow this up just so you can all see this. Here we have an image that says 90% of selection. So this is effectively saying that 90% of this audience area is within this value. Okay, so we're currently within probably about 7 dB or so. Okay, 90% of the venue. We then have the average SPO level in dBA, so it's 96.8. It's 96.8 dBA. We then have included receivers, so this will show you if we are including all the receiver points that we're using to make this calculation, or if we are not showing calculation in certain areas. And then standard deviation, which shows your mean deviation from one receiver to the other throughout your calculated environment. So throughout the surface area, the audience area, the standard deviation is the mean deviation from one virtual receiver to another. So from one virtual receiver to another, we've got a standard deviation average of 5.1 dB. It's okay, but it's not great. Hence why we need some outfill. So what we're going to do now, please, is can you please model both system outfill and mains together, if you can, please. So what we're going to do here is we're now going to unsolo my mains. I want to stop that calculation for a second by cancelling the calculation in the bottom right hand corner. And I'm going to mute my subarray. I want to show the relationship between my mains hangs and my outfill hangs with my subarray muted. So that way I can do that. And now I can just make sure that we're maximally attenuated, A-weighted, 20 hertz to 20 kilohertz, broadband, pink noise. Let's go for a calculation. Again, distribution tool will only be available once the calculation is completed. Okay, so it will always come up blank until the calculation is finalized. And as you can see, again, obviously, because it's the first time we've actually calculated our outfill, it's taken a little bit longer again just to recalculate the relationship of all sources in the model. Apologize, everyone, just seems to be taking a little while. Again, if you've got any questions at all, just shoot them in the chat. I can answer them part by part as they come. Got a couple more things to look at, and then we'll just answer any questions and have a chat about anything anybody would like to discuss in regards to the software. So, perfect. So here we are. So we've now got mains and outfill showing coverage. We can look at our distribution, and then with the addition of outfill, it's now showing that we have an average level of 102.6 dBA, standard deviation between each receiver at 2.3 dB. All receivers are included, and 90% of the selection is within 3 dB. It's pretty much within the ballpark of where we need to be. It's really, really good. Perfect. What I will now mention as well, actually, if people haven't done it before, is save. So here, obviously, we can save our project and create a destination folder for what we're doing. So it might just be worthwhile saving on the desktop as display training. You could even, if you want to, create a new folder in your desktop, display training, or include it again in the folder that was supplied to you earlier with all the resources in that folder. There, save. Just so we've got the file saved. It's never nice losing a file that you've worked for a little while on and it crashing or something happening, and you forget to save and closing the application and losing all your hard work. Cool. So as you can see now, much improved distribution. We're within 3 dB, standard deviation of 2.3 dB, really effective coverage throughout. Now, what we can also do here is we can actually use and I can show you and start to use our frequency response tool. So the frequency response tool, if you click this button, please, will bring up as an early version of a tool to display frequency response at any position on the surface. So here, as you can see, now my mouse cursor is turned into a virtual receiver. You can see that the details on this information, I've got my coordinate information as to what listening height I am in blue, where I am on Y in green, and where I am in distance on X in red, and then with the relative dBA value that I am, direct SPL value that I am at that position on the surface. And as you can see, these black dots that they're jumping around, these are all receiver points that software is using to be able to dictate and calculate the SPL value based on the speakers and the placements and the design that you create. Now, when the frequency response tool is opened, in this mode, the nearest calculation point to mouse position is highlighted by a black dot, displaying those values. Clicking anywhere on the surface, if I click anywhere on the surface, it will fix that tool at that position and disable the scan mode, so that I can see what the specific values are at that specific space, at specific place in the environment or in the audience area. To be able to then get back into scan mode, where I can then go through and scan to a different position, I come back to my tool, click SPL scan, and now tool mode is now engaged back to be able to scan throughout the venue to achieve a position that I want. The graph toolbar above contains the expected controls for smoothing, scaling, exporting graphics or data, visual data. And we can also, as well as analyze frequency response, we can also analyze phase. So we can actually see the phase response of our loudspeaker system, which is useful, obviously, to compare in the field when tuning and as a reference for alignment between sources. So what we can actually do here is set this toggle button here from no phase to dual plot or overplot. So dual plot will give us frequency response at the top and phase response at the bottom. Overplot will plot the phase over the frequency response to show us where our phase coherence and what our phase coherence is doing. The plot type controls whether phases, yes, where it's displayed underneath or on top. Sorry, my document is glitching out a bit. Also, just to let you know, the frequency response and phase response tool can remain open while changes are made to speaker properties, whatever it be that you need to make to be able to change those properties and assign or select them within the file. And they will update with SPL mapping calculation updates as well. What I would like you all to do now, please, is set your input spectrum settings, please, to this following settings in the guide, or just follow me. So we're going to go to sub 30 hertz, broadband, C weighted. We're going to go to our subwoofer group. So we come to subwoofer here. And now we're going to solo our subarray. And now you should have an image that matches this below. Okay. Now, just so you're aware, earlier, I showed you this earlier, but just to go through it, to be able to visualize your coverage, especially with low frequency coverage in greater detail, you might want to decrease your SPL range. So just to let you know, by decreasing your SPL range, more in keeping with what you're going to effectively experience, then you can clearly see there quite pattern change. And as we can see there, even though it's black, it's still 85 dB. Blue is at 89, if you will, to 109. So it's still not quiet. It's still nothing. But obviously, it's good to always know that if you actually just want to see what you're doing pattern-wise, reference-wise, it's easy to do that by just jotting down the range in your settings, just to make it effective in looking at what your coverage is doing. Remember, if you want to analyze the SPL specific loudspeaker groups, you must always solo that specific loudspeaker group, as clicking Calc SPL will calculate all loudspeaker sources in the project based on the SPL parameters you set. Okay, so always make sure that if you just want to see individual sources in groups or source groups, that you solo those sources. What I'd all like you to do now, please, is calculate for these settings and go back to a full system setting. So I'm going to unmute my mains. I'm going to unmute my outfill. I would like a full 20 hertz to 20K A-weighted calculation, please, using pink noise, but including both our mains, our outfills, and our sub. And then we're going to calculate. Perfect. So now you can see we've got mains, we've got outfills, and we've got subarray, we've got distribution, which is within 3 dB. It's perfect. Average level 102, perfect. The only thing now that we probably need to look at implementing is probably just a little bit of front fill, just here in the near field, just to fill in this little bit of coverage and gap, just for the people stood here against the crowd barrier. but also to help with people within the near field that are not probably quite within coverage of the arrays, to kind of get that acoustical image happening from stage. So they're not stood right in front of the stage looking at somebody with the acoustic source coming from above their head. It's coming from in front of them where the source is, where the person on stage is performing that instrument. So what we need to do now is get some coverage in the near field. So we're going to deploy some front field and help us to improve our coverage further. So for this, what we're going to do is we're going to go through native speaker, and we're going to add a speaker natively. Okay, so to do that, we're going to come up to the top here by click add speaker. We are going to come down to a cabinet that we feel will be adequate for our front field requirement. So we're going to use, in this example, obviously we could use other wavefront position. We could use WPM, WPS, possibly even WPC if that's all you had available. But for this example, we're going to use the Taurus T12 cabinet, which is our constant curvature cabinet. And we're going to click add. As you can see, it will import that at 5 meters in the air because that's the setting we have set up. So at 5 meters in the air out the origin point. What we now need to do is create a source group called front fill, so that we've got a source group for our front fill. And then add our Taurus T12 cabinet to that front fill group. What we're now also going to do with this Taurus cabinet is move the cabinet to the correct position and coordinates where it needs to be. So to do that, X, we require it to be 21.3 meters, please. And then Z is 1.6 meters. As you can see now, we've now got the cabinet on top of the first central subwoofer in the array, sat there, ready to go. Once you've added that speaker, we now need to change the actual type of Taurus T12 cabinet this is, because as you can see, this is the 15-degree option. We actually need the 30-degree option. Okay, so to be able to do that, make sure that the Taurus speaker is highlighted. We can come down here, okay, to configuration, where we can come to setup and say that we don't want the 15-degree option, we want the 30-degree option. And it will change the cabinet for the 30-degree option outright. Like so. Due to the changing cabinet, we now need to ensure it's splayed correctly on top of the sub, because as you can see, it's not going to sit like that on the sub in reality unless we actually physically put a bit of wood or something underneath it. So what we need to do to change this so it's deployed sat on top of the sub as it would be, is we need to change the aim angle 30 degrees. We then need to change the X angle to 21.24 meters, and then the height to 1.48 meters. That now will ensure that that cabinet is sat directly on top of that subwoofer as it would be in reality in the real world. Once you have the T1230 chosen instead of the T1215, what we then need to do, and I'm not sure if any of you are aware of this, but with Taurus T12, it has you're able to decide the horn orientation of the cabinet. So the horn orientations, you have 3 values. You can either essentially have 60 degree wide with 30 degrees either side of the horn. You can have 90 degrees wide with 45 degrees either side of the horn, or you can have an asymmetrical offset orientation where you have 30-45 creating a 75 degree asymmetric. So what we're going to do here is, because we're going to be using this for front field going to be in the near field, and we want them to cover as wide as much as possible, we're going to set our horn to 90 degrees, meaning that we've got 45 one side of the horn, 45 the other side of the horn, giving us 90 degrees in total. As you can see here, we can also set it to 60 degrees, which is 30 and 30, 90, and then you've got your asymmetrics, should you want them, depending on what you're trying to achieve. For this, though, again, we're going to go 90 degrees, so that we get as much dispersion as wide as we can from the cabinet in the near field. We're then going to move this Taurus cabinet on Y on the horizontal axis, please, by minus 2.2 meters, okay, which will take us to the next stack or element in the array. And you should now match where we are in the image below, in the image shown, sorry. Now, we're going to be planning to use Taurus T1230 across 4 positions on every other subwoofer, okay? So we're going to have one here, one on the end here, one on there, and then one on the end there, okay? What we're going to do is add an additional T1230 cabinet and place on top of this far stage right subwoofer stack. So then what we can then do, again, is go back to using the symmetry tool we created earlier, where we then create symmetrical partners, or better yet, create discrete partners without using the symmetry tool, because obviously we require discrete inputs, discrete time to each source possibly for our tuning and our alignment. So it's always good to be aware of how you intend to actually process and actually use these loudspeakers in context to circuits, what amplifier channel and circuit they're going to be on, what processing is required to achieve your coverage. So to do that, what we're going to do now is show you a quick way to be able to add speakers that are already contained in the project. So to do this is to use duplicate function. So there are 2 ways you can do this. You can either click and highlight a speaker and then come up here to duplicate, or quicker yet, click and highlight the speaker, right click the speaker and click duplicate. This will duplicate the speaker plus or minus 2 meters on the y-axis, on the horizontal axis, from its current position, okay? Use the following position coordinates to place your additional front field cabinet. So we wish this additional cabinet to be on Y at minus 6.7 meters, placing it directly on the stage right, far stage right element within our subarray. Now, as I said before, please be aware of using symmetry tool, because we could come back to loudspeaker, we could come back to our speaker tool and start to create symmetry by creating symmetrical partners, and doing that by creating symmetrical partners, for example, there. However, obviously now what's going to happen is once we add a time into that for that alignment for that source, it's going to add the same time into that source, which we just don't want unless it's something specifically you want to do if you're limited to the amount of circuits you have available, the amount of amplifier channels you have available, for example. So in this instance, I'm not going to use a symmetry plane. So I'm just going to come here. I'm going to get rid of my symmetry plane so it's not there. And I am going to delete that loudspeaker by pressing delete. And delete that loudspeaker by pressing delete. Now, what I'd ask you all to do, please, is create the additional 2 sources that we've discussed, please, based on the duplicate function. So I'm just going to right click, duplicate this, move this over on Y until I'm in the right space, right place. And then again, I'm going to duplicate this again until I'm back over in the right place in space. Like so. We now have our front fill in place. Now, once we've got everything in place and you've got your front fill in, and you've got your front fill there, please show an SPL plot system broadband A weighted. So again, with full 20 Hertz broadband, 20 Hertz, 20 Hertz to 20K broadband A weighted, maximum input level. I'm going to make sure that all of our Taurus front fill is good, outfill is good, mains are good, and subs are good. Maximum input level, click calculate. This is now going to update the whole image, obviously showing mains, outfills, subwoofer array, and front fields. Do apologize, I'm just waiting for the model to update and map. Does anybody have any questions whilst we're waiting for this, just to render quickly? Do apologize, everyone. My computer seems to be struggling a little bit between doing a video call and the processing at the same time. So please bear with me. And we can still kind of see here that we're still a little bit quiet, really. We see that we've improved it from what it was, but it's still a little bit quiet, isn't it? So what we might actually want to do, to be fair, is probably increase the level of our front fill, and probably our subs for that instance as well, as I have noticed that our subs are a little bit quiet, and probably do need a little bit more level to match the mains. So what we'll do is, once this is updated, or what I might just do actually is just quickly just stop this calculation. I can then update and increase the values. I'm going to increase the level of the front fill. So here I can come to my front fill. I can come to the global parameter. I'm going to bump that up by about 6 dB. I'm going to bump the subs up by about 6 dB as well, just to give them a bit more. And obviously we can turn them up if required, any further if required. Let's do that. 6 dB in the front fill. Let's click maximum attenuation. Perfect. And then let's calculate a full 2020 A weighted maximum pink. Let's calculate. some reason it didn't like the glitch before. While we're waiting for this to render, I can mention things. I can mention a few little things as well, just tools based on what we're doing here with frequency response and subwoofers and front fill and all of that. So in future releases, we are going to be containing alignment tools. We're tools that essentially help you help ensure the system is tightly aligned between sources. So there will be the ability for a tool to be able to know, for instance, time values based on where sources are in space. Because obviously currently we will, when we're doing a design display free currently, because the alignment tools are not available, we will apply the geometric delay, so the path difference between the reference point and the acoustic center. So the reference point of where you are taking your measurement from, and the acoustic center of each loudspeaker or source that you're wishing to align. So mains and sub, for example. When in the field, then you can then take your measurements to ensure that we've achieved the required phase alignment between sources and the target curve that we require for the event. And there'll be a tool for all of that to give you all the values and all of the processing that you require, which again will then have an export tool that you can export straight into amplifiers and settings, so that it makes it very quick, very easy to deploy to create fully coherent phase aligned systems. It's really, really, really quite cool. Just so you as well, some of you might have quicker computers than I have. Once we've completed this, it will be the end of the training and the end of the session. What we would usually do then at the end of creating a design is provide screenshot images for clients. So it will be there are usually free bandwidths we get asked to look at and provide as kind of common calculations, if you will, that people use as a reference point. So, for example, you may have noticed that we've been using quite a lot of broadband 20 hertz to 20k A-weighted calculations. It's a very common one to see essentially how that PA system is going to perform when humans are sat in front of it, stood in front of it, listening. We also get asked quite a lot to provide 500 hertz to 10k, just to show kind of the upper frequencies within the system before getting to either extremely low frequency or severely high frequencies. And then, like I said earlier, another go-to requirement is 4 kilohertz, 1 octave, unweighted, so that we can actually see what acoustically is happening around kind of our speech intelligibility bandwidth, and effectively what voice should sound like or be like acoustically in a space. So yeah, so once you've got your rendition, let's have a look now. Now we've got our front fill in. We've got 103.4 dB average SPL level. We're easily within 3 dB throughout our audience area. All receivers included, and our mean difference from receiver to receiver is 2.1 dB. So majority, over 60% of that audience area now is basically experiencing 104 dBA as an average SPL level. If we go through with our microphone and our point, we can actually see that we've got really nice, and we've probably got 104 to about 106 dB throughout the audience area, 106 on axis in the center, 105 up to 104, all the way up to the back of the audience areas, 105, 104, 103. So really nice coverage all the way throughout our audience area. Obviously going out to the extreme sides, we're going to get some attenuation level as you would expect over distance, but predominantly that's a gig. As far as I'm concerned, it's really good. That will do the job. And then, yeah, and you may want to look at taking slightly different approaches, depending on if there is actually a lot of audience required in these corners. You might want a bit of ground stack PA out here somewhere. It's really entirely up to you and how you do it. It's up to your approach and what you have available to be used and deployed. But yeah, so once you are finished and once you're happy, just to give you a quick mention, there is also 3D screenshot tools to allow you to save screenshots easily and quickly. So for example, this tool here will save a 3D screenshot into your clipboard. The image can then be pasted where required, because it would be essentially, if I take that screenshot there, take that one, I can then paste it. It'll be on my clipboard, ready to be pasted into a document. Or I can either save the image here by clicking this. It will allow me to save that image into a system directory or folder of my choice. If I'm, for instance, creating a folder of images for a report for your client, for example. Really, really handy to use. Really, really, really handy quickly to get screenshots out. So yeah, also worth mentioning, if you have a speaker highlighted when your screenshot tool or save image tool is used, then the loudspeaker inspector, okay, so this information, all of the position information, configuration, labeling information, and weight information will be included in that screenshot as well. So it's really, really handy. So now all I ask essentially is if you could just create some screenshots using those tools, please. And I'll ask if we could create, we would like broadband A, please, 20 hertz to 20K broadband A of the complete system, 500 hertz to 10K of the complete system, and then 4 kilohertz, 1 octave unweighted of the complete system. So let's do that. So we've got A weighted, let's do that. So we're going to take a quick little screenshot of this. Again, I'm going to save this into my little folder that I've created today for training. Let's do new, let's call it screenshots. So it's there. And I'm going to create that. I'm going to go broadband A weighted, save, and do distribution again. I then want to save that image because I want to show you distribution, SPL distribution as well, and call that broadband A distribution. We're then going to go 500 hertz and kilohertz unweighted, maximum input level, calculate. Let that map, see what that's showing and what that's doing. It's going along, we'll just take screenshots of this. Perfect. So now I can save screenshot. Same folder, I'm going to call that 500 hertz, 10 kilohertz Z. Okay. Distribution again, steps are free, it's easy to read. Save the image. It's going to be distribution. Perfect. And then last one, we go 1 octave. We go focal 4K. You can see it already sets the center frequency at the correct frequency based on 4K. Unweighted, maximum, calculate SPL. Now we can see what vocal intelligibility is going to be. Effectively frequency coverage from 2000 hertz up to 8000 hertz, which is 4 kilohertz 1 octave. There we go. And as you can see, now it's done the initial calculation with all the sources. It gets quicker and quicker every one you do. Perfect. And then here, 4 kilohertz 1 octave. Unweighted. Cool. And then distribution, again, the increments are free. Save image. Maybe that distribution. Save. Yeah, and there we are. And that's it. I'm just going to click project save just to make sure that we've got the folder saved and everything's there. But yeah, and now you should have images that match all of the images in the workbooks that you were provided with at the end of the workbooks, which will give you essentially all of that. And yeah, it's all good. So yeah, that effectively is where we're at with Display Free right now. As I've said, there are going to be many future editions coming in the future with future updates. Timeline on those at the minute, there is no specific timeline as we are working very much towards having native optimization in Display Free. But at the precise moment in time, obviously, we still need to use Display 2 to create our array presets, which are then imported directly into Display Free and then show that to be used, and then you can show your clients pretty pictures. I'm just going to open up now. We've got 2 or 3 minutes before the 3-hour timeline that I said this probably would about take. If there's anybody that has any questions whatsoever, now's your chance. Just open your microphone, shoot me a message in chat. If there's anything you'd like to ask specifically whatsoever, please, now's the time. Give me a shout. I'm here for the next couple of minutes. For anybody else that needs to leave or anybody that's there, thank you for attending. It's been very much appreciated. I hope you found this worthwhile. If you require any more information or anything like that, please contact either myself at technical@martin-audio.com or give Berenice, Carlos, or Oscar a shout. Between all of us, we can help support what needs to be done. To answer Whitson's question, Display Free will give us rigging points. Yes. When you have, for instance, an array in there, it will tell us if on a single point, what hole needs to be on the frame to achieve that. It will also, if you can open your cameras for a screenshot, that will be great. Yes, you can. So, for instance, you can have your camera mode and you can set the camera's modes, and then you can take screenshots from those specific positions. And we'll do that. I'll open my... sorry, Berenice, you're talking to me. I apologize. And just to let you know as well, Whitson, not only does it give us the pick point hole from where we're working, you can also look at the configuration. Now, obviously, it's grayed out because we don't want you to change the angle relationship because it's been optimized by Display 2. However, if you look, you can actually see all of the various separate angles, how many boxes there are, what type of frame is being used in, what type of box, etc., etc. So you can really get the information you need to. Obviously, everything to do with rigging, trim height, array angle, that kind of thing is also available in here as well, but usually would be the file that's sent to your PA techs or to your system people or your crew on site via the Display 2 file, as usual. All right. Let me take my camera. Dun, dun, dun. I'm just going to stop sharing. No, you are very. Is that like? Dun, dun, dun.
Ok, ok. Si pueden ir abriendo sus cámaras para tratar de sacar una foto de todos los que estuvimos en esta sesión, sería fabuloso. Muchas gracias, gracias a todos por Roger, gracias Shirley, Raúl, bueno, a todos, muchas gracias. Thank you, Paul, first of all, and thanks for everything about this session was amazing. So thank you guys from Jamaica. If you can open your cameras as well to get a screenshot for our records, it will be great. So let's hope them. Yes, Whitson, thank you. Thank you for assisting, Fabio. Thank you, Brazil. We have Venezuela, Brazil, Mexico, of course. Jorge, hey. We have here, I think Colombia, where is it? I saw them here as well. Colombia were here. And Argentina was here as well. So thank you everybody for being here, for assisting to this training and webinar. So thank you, Paul, for make this happen. Gracias, Fer Zurbarán, ya te vi. Eso, siempre ocultas la cámara, pero bien, perfecto. A ver quién más, a ver si anda Juan Macasquero por ahí para poder abrir su cámara. Y el Inge Aguilar, Carlos Quevedo, a ver si alguien ya se durmieron por allá. Pero bueno, vamos a sacar la foto, ¿les parece a las de 3? Para que eso, gracias, Carlos. Gracias, Edgar. Gracias. Ay, a todos, muchas gracias. Arturo, gracias. Ya te vi por acá, muchas gracias. ¿Les quedó alguna duda o algo? Mándenos sus preguntas, o está el correo de Paul también. If anybody has any other question, as Paul was telling us, so you can get support on technical, and also with our team here as well, Carlos Aldaman, Oscar Tobar as well. They can also support you. Thank you. So let's say Martin, so that everybody can be smiling, okay? Vamos a decir Martin, y a la de 3 cuando diga Martin, todos sonriendo. ¿Ya estás listo, Aldama? Va, ok, listo. 1, 2, 3. Martin. Ready. Thank you very much for your time. Thank you, Paul, once again. Thank you, everybody. Gracias a todos. Y nos vemos en la próxima, que hay uno de Display 2, el 26, en español. We will have another session for Display 2 in Spanish, but we can do that translation as well in English if it is needed. So let us know.
Thank you very much, everybody. Thank you for attending. Glad to have met you all. And if you need anything at all, happy to give me a shout. Give Berenice, Carlos, or Oscar a shout. We're here to help. No problem at all. Have a lovely day, everybody.
Thank you, Paul. Gracias a todos.